All right, so what questions do we have first of all? Yes.
I have a question on number 81.
81C.
Back to the.
Huh?
Start with the beginning.
But I don't have a question on the beginning.
She raised her hand, so. 81C, okay? Says a contestant takes 6 seconds to reach the ground from the top of the zip line. At what rate is the contestant moving down the line? And at what rate is the contestant dropping vertically? Okay? Now, first of all, you need to find part B. The number of feet the steel cable was. How long was that?
50 square root of 2.
Yeah, it was 50 square root of 2, which, you know, that's like 70 point something. Okay. The angle of elevation, you guys found that. That ended up,
45.
if you just use the logic, thinking about it, it's 50 and 50. That's an isosceles right triangle, so it's 45 and 45. Okay. So now we can take a look at C. If they take 6 seconds to reach the ground, and then they're covering this distance in 6 seconds. So 50 radical 2, which, what was exactly? Was it 70.7? Okay, so 70.7 feet in 6 seconds. Okay. The first part is, at what rate is the contestant moving down the line? That's this speed right here, which comes out to, what was it, 11.8 feet per second. Okay, so that's feet per second. 11.8 feet per second. But again, that's down the line. Okay. Now, the second part of this question might have been a little bit of a challenge, especially if you've never had any kind of physics at all. Okay, because really, this is dealing with what's known as with the mathematical concept of a vector. They're not talking about vectors, but that's really what we're talking about, or what we're working with here. At what rate is the contestant dropping vertically? Okay, so
Can you set it up like 70.7 over 6, and then equals to 50 over x?
We use the potential energy equation for this one.
Because we have the feet, we need the seconds.
well,
And then we
really,
diagonal cross multiply.
I'm trying to think if that'll work or not. Really, the easiest thing to think of, though, is to think of it kind of like, again, a right triangle, but in this case, all of the sides we're thinking about speeds. Okay? So here, this is 11.8 feet per second.
Then we can get
Okay.
out too.
But this is still going to be a 45, 45, 90 right triangle, right?
Yeah.
So how would I figure out what this side is?
Divide out
Divide
two.
by-
Yeah, divide out the root 2. Remember, this is the side times root 2 to get 11.8. So if you do that, you get whatever 50 divided by 6 would be. So 8 and 1/3.
Yeah, 8.3438.
Okay, so yeah, we end up rounding that. So 8.34 feet per second. Okay, and that might be important if you're designing this thing to figure out, hey, how fast are people going to be hitting the ground at the bottom of this thing?
Shouldn't it technically be faster if you just drop them down?
Yes.
Okay.
Well, but here's the thing. Well, no, understand what's happening. This is what's actually going on. Because you're falling at an angle, you're not falling as fast down as you could be.
Okay.
If it was just a free fall, we'd be going faster than 8.34. Okay? But because it's an angle, you know, some of this speed is horizontal, some is vertical. Okay? So you're kind of distributing your fall there. Yes.
I have 2 questions. First, where does the 50 root 2 come from? Is that just from using
Yeah, that's the 45, 45, 90.
and what 70.7 feet? Like where is the?
That's 50 root 2.
Oh, okay.
Yeah.
That's it.
We covered that distance in 6 seconds.
Like this, it looks like the vertical is lower than the zipline fall. It says the vertical will be 8 feet per second. Then
Yeah, and this is 11.8 feet.
per second.
Mm-hmm.
But when you're falling vertically, shouldn't you be faster?
Well, if we were actually just falling straight down, but it's kind of like this. I mean, if I have this just in a free fall, it's just going down.
Yeah.
But if I were going like this in the same amount of time,
Yeah.
I'm covering, you know, the distance is decreasing less because I'm not just going straight down, I'm going at an angle. This is why when you're flying, you know, they don't just kill the engines right above the landing zone and just let the airplane fall straight down, okay? Because obviously we call that a crash, all right? That's why I think for like the jets or whatever, they usually do like an 8-degree angle or something like that. I heard it one time. The jumbo jets will do like an 8-degree angle and it gives you a nice smooth landing usually, okay? If you're a fighter pilot landing on an aircraft carrier, I think they've got to land at about a 15-degree angle, which is they hit the deck a lot harder. If you did that with passengers on board, you'd probably have some injuries and definitely a lot of complaints. Okay, so, but this is why right here. What we're doing is we're dispersing the speed that we're going and making this downward vector
Excuse the
essentially smaller.
interruption. Will Cornelius Riley report to the Athletic Center at this time? Cornelius Riley.
So, you know, that's why they go at such a gradual slope, is so that this speed going straight down is less, therefore meaning we hit the ground a little less forcefully. Okay? So, cool stuff. We'll study vectors a little bit later on in the year and look at that a lot more closely. Any other questions from the homework?
Did you see the evens? Can we do some of the first ones?
Let's see, evens up here, or wait,
Yeah, some of the first ones. Yeah, like this.
up here, okay. 48's there, but let's do 46 here, okay? You had 2 options basically. You could either use all the identities, or you could draw yourself a picture. Okay, and you're gonna hear me tell you draw yourself a picture a lot as we do trig. Okay, what I would do right here is first of all do what I can with the identities. All right. So for example, since secant is 5, cosine is 1 over 5. Okay, good. 1 over 5. Because secant and cosine are reciprocals.
Do we assume that it's a right angle triangle? Right triangle?
But it actually doesn't matter what triangle we're in. Secant, if secant is 5, cosine will always be 150.
No, because like if you get like 2 of the points, then you can use a squared plus b squared equals c squared.
Well, yes, you're right.
So do we
But
assume that it's a right triangle?
we can always make it into a right triangle. So yeah.
Oh.
Okay. Now, since we know tangent, we automatically can figure out cotangent.
1 over 2
It's-
to
You can also find sine.
1 over 2 root 6, which would be, if you rationalize that, root 6 over 12.
You can
Okay.
also find sine.
See, that's the decision.
Okay. Did you guys hear that? since we know tangent and now we know cosine, sine over cosine equals tangent, right?
Yeah.
Okay, so I'm trying to figure out what sine is, and I know cosine is 1/5, so sine theta is going to equal, if I multiply both sides by cosine, the tangent was 2 root 6 times the 1/5,
It's 0.9797.
okay? Or you can just leave it as 2 root 6 over 5. That would be fine too, but that's the sine of theta. Alright, does anyone have any questions about that part?
For C, we just subtract. We change 90 degrees to radians. Like pi over 2 is minus root 6 over 12.
You don't have to. I gave it to you with pi over 2's, but if you're already in degrees, it's automatically going to be 90 minus theta. Okay? So, what is Jacob talking about using when he sees the 90 minus theta? What? Yeah, it's the same as 1/2 pi. What identities are we going to use right here? Cofunctions. Good, Derek. Cofunctions. So the cotangent of 90 minus theta is the same as tangent of theta, okay? And we already know that tangent of theta is 2 root 6.
Why is cotangent 90? 1 over tangent theta is cotangent. Is cotangent part.
You're right, okay? But this one is cotangent of 90 minus theta. That was one of our identities, the cofunction identities.
How many of those are we gonna have in the quiz?
Oh, you can use step words and.
Yes.
How many
Yes.
are we gonna have in the quiz?
How many what?
Think of those problems.
Well, I
The whole
don't,
quiz.
actually, I don't think I give you any of this exactly, but the concepts are there. I mean, you're gonna have to be able to use some identities, and that sort of thing. You should know them, yeah. I'm not gonna ask you to write out all the identities, but you should,
I mean, a cheat sheet kind of thing.
that's good.
Well, no,
Can we use
but
it on
like,
a graph?
Yeah, no, you gotta know these guys. Cause here's the thing, you can't be, listen, you can't be constantly going back. It's not that you're gonna remember everything forever, okay? But you can't be constantly going back and looking everything up. You've gotta, in math, you've gotta memorize at least some stuff, okay? Now, for the IB exam, there are certain ones that they have a whole formula booklet. If you guys go on to take the IB SL2, they've got a whole book full of formulas that they give you. The fact of the matter is, though, also, it's a time test. So if you're having to look up everything, you're never going to finish. So, but again, that's only if you're taking IB. If you guys do AP doesn't give you anything. You got to memorize everything. So it's kind of a trade-off. But anyways, you guys need to memorize these relationships, okay? Hopefully, as we use them, you're coming more and more familiar with them, okay? All right, let's see. What other questions do we have? Oh wait, here was one. This one was interesting. 54. We did this one third period.
Foil, right?
There are two ways you could have done it. One would have been to foil, and you would have gotten this. And then, if you remembered your Pythagorean identity, you could have noticed, hey, cosecant minus cotangent is 1, so you're done.
Cosecant what?
Okay? Cosecant squared minus cotangent squared automatically equals 1 because of this Pythagorean identity. Alright? So you could have been done with this in 2 steps. That's That's your answer. It's a proof. Okay? The alternative was if you made everything in terms of sine and cosine, like we did up here. Okay? You do have common denominators, so you can add 1 plus cosine over sine times 1 minus cosine over sine. And then you're multiplying the 2 fractions together. Okay? And you have conjugates in the numerator, so it's 1 minus cosine squared over sine times sine, so sine squared. And then again, you have the Pythagorean identity here. If I have 1 minus the cosine squared, that equals sine squared. Okay. And of course, sine squared over itself is 1.
Will this kind of question be on the quiz tomorrow? This kind of.
What, you guys just want me to give you the quiz today so you can look at it overnight?
Yes, no, I would still do bad. I mean, like,
No, you wouldn't.
should we expect, like,
Now, you guys, I'm not going to give you a super complicated proof or something like that, okay? But you need to know your identities, okay? And you need to know them well enough to where, it's not like it's second nature necessarily, but you shouldn't have to, you shouldn't have to be real dependent on a paper while you're practicing, okay? At this point, tangent equaling sine over cosine, that should be easy for you. The sine squared plus cosine squared equals 1. That should be familiar enough to you. And then, remember how we got the other 2. You may not remember the other 2, but you should be able to get the other 2. Because I showed you how to derive those. Either divide by sine squared on all of it, like we did here, or divide by the cosine squared, and you get the other one. Okay? So, Yash.
Do we need to know the formulas like theta equals s over r, converting angles to radians?
You should know how to convert angles from radians to degrees.
But we don't need to memorize the formulas, right?
No, as long as you can do it.
Okay.
Yeah. Alright, anything else from homework? Okay. Now, there we go. What we're going to do the rest of today is we're going to start building our unit circle. I'm going to hand this out to you.
Remember those gallon men used to make, like,
Yeah.
the gallon men?
And there was
Gallon
a posted
men,
in court.
Oh, I remember that. I made that one up for
Forts or pints or
I just remember it very well now. I completely forgot the
Oh,
second out of second.
yeah.
We had to learn that in 7th and 8th grade.
Are we going to be able to play
Home ec. Guys took home ec
What's homework?
1 year and we took manual arts another year.
My whole high school, they had cooking, like,
Yeah.
major. We had the culinary classes.
That- Yeah, we did cooking
All the
in
culinary
7th
kids
grade.
at my old school, whenever they would make something, they just have a big bunch of everything. Like brownies and cupcakes.
We'll be taking the rules.
Alright, now, I want to mention one thing before we get to finishing our unit circle. And that is a term that I've kind of talked about a couple times already, but I want to officially look at it and explain it and see how it works here. First, it's the concept of a reference angle, okay? The reference angle. Let's talk about what a reference angle is. If theta is an angle in standard position, its reference angle is the acute angle theta prime, which there's no significance to the prime, it's just an acute angle, formed by the terminal side of theta and the horizontal axis. Okay? The reference angle is an acute angle, so a reference angle will always be
Less than 90.
less than 90, okay? don't give me a reference angle of 120 degrees, okay? And don't give me a reference angle that's negative either. It's always between 0 and 90. Okay?
What's
And-
next to the angle 11 R? Or, oh, it's like a little check mark.
It's a prime.
Um,
It's like an apostrophe.
Yeah.
But there's nothing significant about that. It's just how they labeled it. Now let me show you this in our 3 different quadrants. Which, by the way, why don't I have quadrant 1 here?
You already know it.
Because an angle in quadrant 1,
Doesn't have it. It's cute.
it's acute, so it is the reference angle, right? So, but here, if you'll notice, I kind of drew it with the colors here. You have the horizontal axis and the terminal side. The green here is the reference angle. Okay? So here in quadrant 2, you got a reference angle between the terminal side and this positive or the negative side of your x-axis. Here in quadrant 3, again you have the terminal side down here in the 3rd quadrant, and you have the negative x-axis. Here in the 4th quadrant, you have it, okay, down here in the 4th quadrant, and you have the positive x-axis. But it's that angle between your terminal side and the x-axis. Now, figuring out the measurement of this angle is really important. So we'll see in a couple minutes. There are some formulas, but honestly, I don't bother memorizing those formulas. Because if you think, these are easy to figure out. Okay? Keep in mind where pi is and where 2 pi is. Okay? You guys know this is pi, or 180 degrees. You guys know that a full rotation would be 2 pi, or 360 degrees. So think. This one's a little short. It's above pi, so it's okay, so I'm going to have to take pi and subtract whatever this angle is to figure out what that little reference angle is there. Okay? Or you could think of it in terms of how much further do I need to go to get to pi? It's another way of thinking about it. In the 3rd quadrant here, you could think of it in terms of, alright, how much past pi am I? Or how much past 180 degrees am I? And then in the 4th quadrant, alright, how far short of a full 360 degrees am I? So, yeah, there are some formulas, but don't get caught up in trying to memorize them. Just think. Now, let's practice with this a little bit. Okay. You'll notice here's 11 pi over 6. If I think to myself, all right, how much short of a full 2 pi is that?
Yeah.
Well, 2 pi would be 12 pi over 6, so I'm pi over 6 short. There's my reference angle. Okay.
Yeah, I get 2 pi would be 12 pi over 6.
If I were thinking of it in terms, since this is 11 pi over 6, if I thought of it kind of with a common denominator in sixths, that would be 12 pi over 6. So, how far off am I? I'm 1 pi over 6 difference. Do a different color. Let's say I had this angle. Let's say I've got 160 degrees. Okay. What's this reference angle here going to be? It'd be 20 degrees, okay? In this case, I'm in degrees, so that's 180 degrees. and I'm 20 degrees short. So my reference angle would be 20 degrees.
What?
Okay,
Why
Wait,
is it
how
over
is
there?
it that,
for this one.
Off this one.
how is it that the angle is pi over 6 and not 11 pi over 6? Oh, yeah,
What you're thinking is
okay. For the first one.
Yeah. What do you mean, how is it? Right?
Isn't it, I'm confused. We're looking for the red or we're looking for the?
We're looking for the red one.
Oh, okay. I had it backwards, that's why.
Oh, yeah, okay. Yeah, if we were given a negative pi over 6 as the angle, then the reference angle would be a positive pi over 6. Okay? So what good is this? What's the significance here? Alright? The significance is this. If two angles have the same reference angle, then they will have either the same or opposite values of the trig functions.
So it's middle relation.
Now what does that mean? Well, you guys already saw the first quadrant of your unit circle, so you know that the sine of 30 degrees is 1/2. Good, 1/2. The y coordinate at 30 degrees is 1/2. So, if you think about it, what's an angle that has a 30-degree reference angle?
Sine 150.
Yeah, 150. It's 30 degrees short of 180, right? So if this is 30, then over here, if this is 30, this angle here is 150.
it'll still be 1/2, right?
Okay? The sine of 50, or 150, sorry, I automatically know will be either 1/2 or negative 1/2. Now we'll learn later today how to tell which one's which, but that's why these reference angles are helpful. In fact, even if by the time we learn all of this, even if all you remember is the first quadrant of the unit circle, you can figure out all the sines, cosines, tangents, everything for all of the other angles in the unit circle. Okay? So, let's start working on our unit circle and figure some of this out, okay? Here's what you know so far. I'm going to start just with degrees. Here's what you know so far. We start at 0 or 360 degrees, and we go 30, 45, 60, 90. This is what I gave you your handout for, so you could put all this in there. Okay? Yeah, the handout I gave you is so that you can kind of have the whole thing all in one spot. Okay? Now, there's a pattern here. If you remember, to form our unit circle with all these different angles, we cut each quadrant in half. That's how we got the 45 and the 90. Okay. And we also cut each quadrant in thirds. That's how we got the 30, the 60, and the 90. Okay? So I'm going to take each one of those and work my way around the circle. Alright? So let's start with the 45. I start at 0, then I go to 45. The next 45 is here, that's 90 degrees. The next 45 would be here, so that is 135 degrees. Okay? The next 45 is right here, so that's 180. And then the next 45 is here, that's 225. If you add 45 to 180, you have 225. Then if we add another 45, we're down here at 270. Then 315. And then we're at 360.
So that's basically the quiz on Friday, right?
On Friday, yes.
Have two quiz this week?
Yeah, Fridays is real short. All it is I give you a blank one like I just handed you, then you fill it in.
You're doing what?
Can that be tomorrow?
That's Friday.
I haven't had this one tomorrow.
Yeah, me
So,
too.
Yeah.
Well, just.
How much will the quiz on Friday be?
You don't know this?
Like 40?
500.
I think it's,
10.
I forget. I'll have to
I
look.
think, trauma.
Anyways, don't worry about that right now, let's worry about this. Okay, now we'll go through our 30s. Okay, 30, 60, 90,
120, 150,
150, 180,
210,
210,
240,
240, we already have the 270,
300.
330,
and 330. Okay,
I don't think.
so, that wasn't too hard, was it?
Hopefully not.
Okay, there's a pattern to it.
Actually,
And there's a similar pattern to the radian measures too. Okay, I'll let everyone catch up writing. And you can go ahead and write in, you already know the first quadrant for your radians as well. So now, instead of adding 45s, what are we going to add this time? Pi over 4, right? Now, with this you're going to have to be careful because you are going to have to reduce fractions. Okay? So, we have 0, then 1 pi over 4, then 2 pi over 4, which is pi over 2. So then over here at the 135, it's 3 pi over 4. And then 4 pi over 4 is just pi. Yep, down here is 5 pi over 4.
3 pi over 2.
Yeah, 6 pi over 4 will reduce to 3 pi over 2. And then 7 pi over 4. And then 8 pi over 4 would reduce to 2 pi.
How do you get this so fast?
What?
How did you
Yeah,
get?
how do you get it?
Because we're just adding, here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, okay? That's the 45, the 90, the 135, and the 180. Because this equals pi, this equals pi over 2.
Oh,
And then you got the bottom half same way. Okay? So what are we going to add to get all the rest of them? The pi over 6s, okay? And of course on the pi over 6s we're going to have even more reducing of fractions, but it's okay, you can handle it. Okay? So here's, check this out. 1 pi over 6, 2 pi over 6 is pi over 3, 3 pi over 6 is pi over 2, 4 pi over 6 is 2 pi over 3. That was 4 pi over 6, so 150 is 5 pi over 6. And then 6 pi over 6 is pi.
7 pi over 6.
Good, 7 pi over 6. Then, good, 8 pi over 6 is 4 pi over 3. Listen up, guys. This is like one of the most important things we're learning all year, and you need to focus. Alright, so that's 8 pi over 6, which is 4 pi over 3. 9 pi over 6 reduces down to 3 pi over 2.
10 pi over 6 and 5 pi over 3.
Good, 10 pi over 6 is 5 pi over 3.
11 pi over 6.
And then 11 pi over 6 is our last one. Okay? So, there's a whole lot more, if you know your first quadrant, Or really, if you just know pi equals 180, and you can figure out your first quadrant, and then from that you can figure out the rest. Now you need to be able to do it relatively quickly. And by the time we're done, you'll know this very well. Okay, alright?
Yeah,
So those are our radians.
this makes some sense.
Makes some sense, good.
The red one is radians, right?
Yeah, red one is radians. Okay. Alright, so think we'll have enough time to finish the points, or at least to get far enough with the points to where you guys will be able to fill in the rest on your own. Okay? Here's our first quadrant worth of points. Okay, you guys already had this.
We just change the negative sign and the positive sign.
This is going to be
Exactly.
It's easiest one.
Yeah, it's not-
Yeah, Nick just said it. Remember what we were talking about reference angles. If the reference angles are the same, the values of sine, cosine, tangent, all of those are either the same or opposite. So all that's going to change are the signs. Okay? Signs, S-I-G-N-S, not S-I-N-E-S. Okay? The positive or negative.
Is this going to be the quiz on Friday as well?
This essentially is the quiz on Friday.
Right, yeah.
Basically, write all of that. We'll get there. Okay? Okay? So let's start with the easy points. Up here, what's this point? 0, 1. Okay? What's the point over here? Negative 1, 0. Good. And this point down here. Yeah, there you go. Please don't miss those. Okay? It's been done.
Those are tricky.
Now, look at the reference angles. By the way, which degree or which angle measurement is easier to recognize the reference angles with?
Degrees.
45?
No, radians or degrees?
Degrees.
Radians, why?
Because you don't write your
¿Por
angles.
qué? Porque sí.
Oh, I got this.
Yeah?
It like follows the line that you break it down in. So, for root 3 over 2 comma 1/2, if you follow that line, it's just gonna be that same exact thing with
Okay.
the sign.
7 pi over 6 has the same reference angle as pi over 6, yeah.
So it'll be like negative 3 over whatever.
Yeah. Now, there's more than just that one though.
Okay, sine's hit y, right?
Yeah,
And then cosine dx, right?
yes.
Okay, so you're gonna use the cosine and sine to find what your angle is of the, right? And
Well,
then,
you use
You're not just.
also.
Hang on, let her talk.
I mean, you're not gonna use like, I'm not explaining.
We're not gonna see like cosecants or anything like that on here, no.
You could use like.
Here's the thing though, look at our radians. Let me show you. This and this, whoops. Not that. And this and this, those are all the same reference angle. What do you notice about all the angles? In radians particularly.
They're all pi over small.
They're all something over 6, right? In radians, it's super easy to find the angles that have the same reference angles. Because the ones over 6 all have the same reference angle, and the ones over 4
Oh.
all have the same reference angle, and the ones over 3 all have the same reference angle. Okay? So, when I have this point right here, the radical 3 over 2, oops, start over, the radical 3 over 2 and the 1/2, okay? I know those coordinates are going to occur here and here and here. Now obviously those are not all the same point, but this is where it's either the same or the opposite. Okay? So think with me. Over here, which coordinate's negative in the second quadrant?
X.
The x's.
All students take calculus.
So, how about down here?
Both negative.
They're both going to be negative. And in the fourth quadrant, y, which is our sign, is going to be negative. Okay? Okay?
And doesn't it just follow the same rules for all of them?
All of them are going to have the same rules here. So if I'm looking at the pi over 3, it's got this point, 1/2 root 3 over 2, and that's, you're going to see that 1/2 and the root 3 over 2 on all those points. The difference will be, though, in the fourth quadrant our y coordinates negative, in the third quadrant both coordinates are negative, and in the second quadrant the x coordinate's negative. And then the same thing is true with our pi over 4. We have root 2 over 2, root 2 over 2. Okay. And I know I'm kind of cheating by cloning stuff, but if you guys see it, I mean, you could very easily do it on your own. Okay? All you need to do is think about your coordinates.
We're putting this online, right?
Yep.
We can print it.
Okay? You got that. Both are negative in the third quadrant. Only x is negative in the second quadrant. Okay, guys, this is where what I mentioned earlier comes into play. Notice everything's positive in the first quadrant.
All students take calculus.
Over here, the y's are positive, which means sine is positive. And since cosine's negative, a positive over negative means that tangent's also going to be negative. Okay? In the third quadrant, sine and cosine are both negative, so when you divide them, tangent ends up positive. And then in the fourth quadrant, cosine is positive, sine and therefore tangent is negative. So, all students take calculus. Shows you what's positive and what's negative. Okay? So you have the entire unit circle. From this now, if I asked you, hey, what's the cosecant of a 300-degree angle? You could see that, well, the cosine of 300 is 1/2, so the cosecant, or I'm sorry, the sine is negative radical 3 over 2, so the cosecant's going to be
Negative 2.
negative 2 over radical 3, so I simplify it, yeah.
That is AS.
You see how that works, guys?
Yeah, I'm trying to write that circle down.
You know, this is
Yeah.
TC.
That's how powerful this is, okay?
My question.
Tomorrow I'm going to give you this,
The whole
On
thing?
Sunday?
Right,
the whole
like this?
thing, tomorrow.
Exactly the same? Like this?
Yeah, just like, well, it's printed in,
With all the greens, the reds?
no, not with the, it's just black and white, but,
I mean, no, with all the data, or just the?
no, it has everything.
Oh, that's
It doesn't have the ASTC, but
So
you
you
should be able to
have
figure
this
that out.
tomorrow for kids.
Tomorrow, you will have that,
That's
Friday when you-
and I'm gonna ask you guys, listen, I'm gonna ask you, hey, what is the sine of 5 pi over 4?
Tomorrow on the quiz.
Sign off.
Yeah,
There.
what's the sine of 5 pi over 4?
Negative
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 2.
root of 2 over 2.
Yeah, negative root 2 over 2. What's the tangent of 3 pi over 4?
Where's the
I'm just.
The tangent
you
is
just use sine
negative
negative 2, negative 1,
No, radical 3 over 2
No.
over
negative 1.
3 pi over 4.
Negative 1.
Okay,
Negative 1.
so when you divide sine by cosine, you get negative 1.
And that's
Okay.
it, that's all the quizzes?
No, that's not all the quizzes,
Oh.
that's on the quiz.
How many questions is the
What is
quiz?
IBSL? Do you know what IBSL?
No, I don't
16?
know. Oh, wow. And that's a
I'm not
feeling,
sure.
right? That's a feeling.
There's 6 of them like
What
that.
is IBSL?
Yeah, me too.
Most students-
All trig functions are positive in the first quadrant.
Oh,
Angles in the second quadrant, only the sine and then cosecant too would be positive. Okay?
cosecant CSC, right?
Yes. So there's our finished product. And I usually write all students take calculus, and I'll write this up on the corner of my paper too,
That's much.
just so I remember everything. Okay? But try some of the homework, we'll answer some questions first, then do the quiz. Have a great day.